All right, we are asked about question number 37 in the homework. Do we need me to keep this up here? If you want, I can take a picture of it, and if we need to, I can post it to Google Classroom and as well as some examples. I think we talked about this the other day, but if we did not, I'm considering, based upon somebody's request, posting solutions to some of the problems, like all the odds or all the evens, as well as my work, so you can see how I worked through that if you want to see that as well. If that's something you guys would be interested in, starting on the next homework assignment, I will try to do that from now on. I thought it was a good thing that they asked for, and I thought it'd be great for you guys to have, so I will try to do that from now on. Remember, I will always take suggestions as best I can. If I think there's a good idea, I will definitely do it.
Is that blue pencil marker?
Put this over here?
Yeah.
Chalk marker.
That's what I was trying to figure out why it wouldn't come off.
Yep. Well, it does come off. You just got to work a lot harder. Okay. Number 37. So just like on the previous ones, how I'm going to use the trig ratio to set up this problem. The difference is going to be they've actually given me the angle, which gives me a huge advantage on these problems. Here we go. Here's my triangle. Again, I'm going to always consistently try to use pretty much the exact same triangle if I can. I'm going to have A up here, C down here, B over there. Give me a little B right there, a little A down here, a little C over here. And I can fill in some blanks here. 37 says side B is 15. So up here, side B is 15. Angle B is 15 degrees. So 15 degrees. Okay. We are tasked with finding the missing sides. Use a calculator to find the length of each side to 4 decimal places. All right. Here's how we're going to do this. Unlike with the previous problems, how they gave us a trig ratio, this time they did not. They've given me an angle. But that does not mean the trig ratios are not useful. So real quick, I'm going to start this problem by listing the different trig ratios for this problem. Example, sine of B. And I'm choosing B for this problem because B is the angle I know what it is. So that would be sine of 15 degrees is equal to the opposite to B, which is 15, of the hypotenuse, which is C. Cosine of B, which would be cosine of 15 degrees, is equal to the adjacent, which is A, over C, which is the hypotenuse. And then tangent would, of course, be tangent of 15 degrees equal to the opposite, which is 15, of the adjacent, which is A. Now, two of these are really useful to us because they have values with one variable. Those two would be the sine and the tangent. Cosine, while still true, and it's going to be true at the end of the problem as well, because it has two variables, I'm going to go ahead and cross that one out as not being useful. It does have properties. It does make sense whenever we finish the problem, but in terms of finding A or finding C, it's the worst one to pick. Now, let's start with the top one. This top one states sine of 15 is equal to 15 over C. Fun fact, sine of a number is another number. Sine is just like any other function. You plug a number in, it will pop a number out. So it turns out this is equivalent to another function, but instead of sine of 15 degrees, I could just plug in sine of 15 and get a decimal. Daisy, calculator please. Make sure it's in degrees. Can you do sine of 15 for me? So on the right hand side, I'm going to have 15 over C. On the left hand side, I'm going to do sine of 15 with Daisy's assistance.
57.95.
57?
15 over the sine of 15.
No.
What?
Just sine of 15.
Sine of 15.
Just. Woo, okay. I was like, I can't write.
0.2588.
0.2588. So now we have a single equation with one unknown. Now I can solve this like we did last week's problems. First step, multiply both sides by C. This gives me C times 0.2588 equals 15. Divide to get C by itself. Now I need that number, Daisy. C is equal to 15 divided by 0.2588, which is 57 point something you said?
57.956.
956. And I know you're wrong, Brian.
9.
Because the
5,
instructions say
Oh, okay.
to 4 decimal places.
9,
You're wrong, Brian. 9, 5, what?
9, 8.
9, 8. So 9, 5, 6, 9, 8?
9.
9, 5, 9, 8. That's before the
5, 7, 9, 5, 9, 8? Beautiful. Okay. And it should be close. If you're just a decimal or two off, that could be because maybe you didn't turn this into a decimal here. You may have saved it as sine of 15 until the end, which is what I normally do, which I'll do for tangent down here, so you can see that version as well. But again, it's the same process as last week. We use the trig functions, but this time they didn't tell us a trig function. We got a trig function from the picture. We got sine because in the picture, the opposite over the hypotenuse is sine. All right, tangent one. This time I'm going to do it without using the calculator until the very end. So first thing I'm going to do is multiply both sides by a. This will give me a times tangent of 15 degrees is equal to 15. I then divide both sides by tangent of 15. I end up with a is equal to 15 divided by the tangent of 15 degrees, which is a decimal. And I want it out to 4 decimal places, please.
55.9808.
Just 4 decimal, please. 55.9808. Beautiful. Brian?
The sign answer is slightly wrong.
Do you have the exact answer?
57.9555.
5, okay. And again, it comes from whether or not you convert the decimal here or convert the decimal here. It's a minor difference. 9555. And like I said, it'll change your numbers just a tiny bit. I tell you give me 4 decimal places because my plan is to look for 3.
Is that
If you give me 4, then it makes sure 3 is right. Yes, ma'am?
the tangent is A?
Yes, that is A.
5.98.
55.9808. So notice how I set it up. I choose the trig functions based upon the picture. So I got tangent by setting up opposite over adjacent. I got sine by setting up opposite over hypotenuse. Cosine is not useful because of how it sets up A over C. And then take each of those and solve them individually for that one variable, and then I have both solutions. I could have also found one of them, C, and then used Pythagorean's theorem. Or I could have found just A and used Pythagorean's theorem. I would have gotten the exact same solutions if I had. I'm sorry. All right, number 37. Do we want to work through like 38 as well? See another one like it? These become very similar to last week once you get past that first hurdle of getting the picture down and recognizing the trig functions using the picture rather than being given the trig functions you're supposed to solve. So let's look at 38. Am I good to erase number 37? Good. Hearing no objections, moving on. 38. I'm going to keep a lot of this picture because, again, the picture is not the important part. The picture just sets up the trig functions based upon their position, not their size. So, coming here, I no longer have the 15, or the 15 over there is no longer 37. We're now doing 38. Let's do it. 38 states we have C is equal to 200 and B is 5 degrees. I'm going to put a 5 degree right here. B over there, and C it says is 200. All right. So once again, I have 2 unknowns. I have A unknown, I have B unknown, I have C known. I have one of the angles unknown. Just like with the previous problem, I'm going to start by listing the 3 primary trig functions, sine, cosine, and tangent. As you get better at this, you'll quickly realize that you're always going to throw one of them away. So you may start looking for that one and going, oh, this is a trig function I should avoid. Let me write down the other 2. Or you can go the other direction and just say, hey, I see this one's going to use sine, I see this one's going to use cosine, I need to avoid this other one. In the end, though, you should end up with 2 functions to work with. Here's all 3. Sine of now 5 degrees, cosine of 5 degrees, and tangent of 5 degrees. Okay, sine. According to my picture, sine is opposite of hypotenuse. Here is the 5 degrees. Opposite of that would be b, and then 200 would be my hypotenuse. Cosine would be adjacent, so that would be a over the hypotenuse. And then tangent would be b over a. And right away I get to that point and I realize tangent's bad. It's got two variables. Cross it out. So let's focus on the sine and the cosine instead. And I'm going to take each of these trig functions that I developed from the picture itself, and I'm now going to set up to solve for the missing variable. I'm going to take this first one, multiply both sides by 200. And when I do, the left-hand side becomes 200 sine of 5 degrees. The right-hand side becomes just b. And so b is by itself. This must be the solution. Now the problem does say to give it to 4 decimal places, so I'll need some help here. Could you type in for me, please? 200 sine of 5 degrees. While you're doing that, I'm going to go ahead and take a look at the next part. Multiply both sides by 200. What did you get, Daisy?
17.4311.
17.4311. Is that correct? Beautiful. Okay, the second one. Cosine now. Different trig function, different fraction, different components, same process. Here we go. Multiply both sides by 200. That'll get rid of those 200 on this side, meaning I end up with just a by itself, which is perfect. On the left-hand side, I end up with 200 times cosine of 5 degrees. Since a is by itself, this must be the solution, but I should have it to 4 decimal places per the instructions. So once again,
199.2389.
let me make one last change. Does it give me a unit of measurement? No, it just says 200, so these two should just be 199.2389 and 17.4311. Now, you might be among the group of people that looks at my picture now and goes, what? That ain't even close to what the picture looks like. Who cares? The picture I made up before I even saw the problem. The picture is only there to help me set up the trig ratios. The opposite, the adjacent, and the hypotenuse. I could draw this beginning picture, like this. Well, hopefully not like that. I could draw it like that. I could draw it like this. I could draw it, on its side somehow. Like, how you draw it doesn't matter because the opposite side is still going to be the opposite side. And the adjacent side is still going to be the adjacent side. The hypotenuse is still going to be the hypotenuse. What it can do is it can mess up your mental view of it when you look at it and go, that's not 5 degrees. What's wrong with you? If that happens, just remember, the picture isn't there to help you except to get the trig functions. That's it. That's the sole purpose in life. So once you have the trig functions, this picture, useless, garbage, trash, like some of you. I mean,
Hey.
Ouch.
ooh, I would never say that about Brian. Okay. Questions on 38. Notice this process is very similar to last time, but instead of being given the trig ratio, we have to find the trig ratio using the picture. Do we want to do 39 real quick, or we want to move on? Like, are there other things you guys want to see? Which one?
Well, you take instructions and stuff.
On like 10 through 16? Want to do another one of those?
Well, if you can just come here and tell me. You don't have to have that.
Well, I'll bet that if you're confused, there's other people that are going to be confused. I know there were people in my first block that I did that were still struggling with 10 through 16. And I'd love to have as much help as I physically can get it.
Okay, well, I'm on number 11.
Okay. Want to do it together? Okay. Okay. As we said before, this problem, I'm going to use the indirect method, which is following steps. Ready? We're going to do Pythagorean's theorem of the trig ratio. Then we're going to set up the two fractions. One will come from the Pythagorean theorem, the other will come from the picture itself.
Okay.
And then once that piece is done, we'll do Pythagorean theorem one last time to find the final solution. Okay? So I'm going to walk through my 3 steps, one little piece at a time. It looks like a short list, and also at the same time it looks like a long list, because no part of that's an easy step. Ready?
Yeah.
All right, step 1. I'm going to do Pythagorean theorem with a trig ratio. So I come up here, it says I have this trig ratio which says sine of b is equal to 1 over 2.
Okay.
Ready? I draw a picture.
Okay.
Let's put b right here. Doesn't matter where b is as long as it's one of the angles. That's not the hypotenuse. So it's sine. Sine is, remember, opposite over hypotenuse. Then I put a 1 over 2. Now notice this is not the same picture as what we have here. Because this one says a is supposed to be 20. I'm going to ignore the a is 20 until the very end. Or until we get to step 2, I should say. Like I said, I'm going to ignore this a is 20 until later. Alright? Let's do it. I want to find that missing side using Pythagorean theorem. So I'm going to do opposite, 1 squared, plus adjacent squared. I'm going to label that as a for adjacent, equals the hypotenuse squared. Now I'm going to shorthand just a little bit here, because I think you're smart. What is 1 squared?
1.
2 squared?
4.
So I end up with 1 plus a squared equals 4. And then want you to subtract 1 to a by itself,
Square equals 3.
and then take a square root.
Square root of 3.
So a equals the square root of 3. So I'm going to go back over this top picture. I know now this trig ratio works. So instead of a, I'm going to have the square root of 3. Okay. Now my focus is to treat this like number 10. Now in number 10, I began the problem by drawing the picture that it's describing with a equals 20. That's what I'm going to do now. So this is background stuff to help me out later.
Okay.
Now I'm going to do the actual problem. Ready? The actual problem has this picture. So very similar. B is in the same spot. And then A is going to go over here, and then C has to go there. And it says that little a is 20. Which means that little b is unknown. Little c is unknown. Ready?
Mm-hmm.
Now, I need to get the 2 fractions. How did I get those 2 fractions before on problems like 10? Well, I used a trig ratio that they gave me. But this ratio of sine won't work on this one. That's why we had to take this step. Because if I try to do sine of b is opposite, a variable, divided by the hypotenuse, another variable. That can't work if I want to do the 2 fractions. So I'm going to use a different trig function. I can't use sine, because sine gives me b over c, 2 variables, bad. I have 2 options.
Do cosine then?
Could do cosine, or I could do tangent, like both work. You said cosine first, that's what I want to do. Okay, so let's do cosine. Now what this means is, because these 2 triangles have the same properties, cosine for this triangle should equal cosine for this triangle. Ready? Let's go to this triangle. Look at the picture for me. Tell me what is cosine of b.
1/2.
For this triangle. So we have the 1/2 from that triangle, right?
Mm-hmm.
No, not 1/2. Be careful.
What do you not keep the one?
We want the cosine. We want the cosine. Okay, so here's b. Cosine, remember, is adjacent over hypotenuse.
So it's 20 over c.
So we do 20 over c. Now look at this picture, which also has b.
Mm-hmm.
What is this one's cosine?
Square root of 3 over 2.
Now you've got 2 fractions, just like the last one. And now everything from this point on is exactly like number 10. So let's walk through it real quick to remind ourselves about number 10. Keep in mind, this is always the case. This triangle always matches this triangle, just at different values. So take a look. Whenever we're finished, I will show exactly what that means. But for now, let's go ahead and find C.
Okay. So
Ready?
Multiply by C.
So we end up with 20 times 2, C times the square root of 3. We end up with square root of 3C. 20 times 2 is 40. Divide to get C by itself. C is equal to, I got a couple different versions of this. 40 over square root of 3. That's one answer. So my picture up here, this is 40 over square root of 3. I could also, if I have a calculator or want to reduce that radical, I could get the reduced radical version. Or I could even get the decimal version. I believe the decimal version is like 23.1. Okay, so this one would be 23.1. Okay. Now I've got two sides. I've used the two fractions to find a missing side. That's step 2.
Yeah.
Step 3, Pythagorean theorem again. But now with these two numbers, 20 and 23.1.
So 20 squared plus 23.1 squared.
Be careful,
No,
it's...
plus B squared
There we go. Yes, good correction.
equals 23.1 squared.
Very nice. Okay, help me solve it. I know 20 squared, that's 400. B squared is B squared. 23.1 squared, I cannot do that in my head, but I can get close. 400 and brain, 476.3.
533.61.
Oh Lord, that's way off. I'm glad you checked me. Okay, subtract 400 from both sides. I would get B squared equals 133.61. Then square root both sides. B equals, and I have a guess. I think it is 11.5 something.
11.559.
9. All right. This is 11.559. Now take a look. We are officially done with the problem because we've done everything it asked us to, but I want to showcase that what we did was right because I can now prove it. Ready? I told you before, these two triangles, the triangle we got from the problem, from the picture, and the triangle we got from the ratio, should have the same properties. Are you ready? Okay, I'm going to need your calculator. Here's what I want you to do. First, let's talk trig ratios. Sine. According to my problem, sine of b should equal 1/2. Now that's easy to see over here because we do opposite over hypotenuse, 1/2, that's 1/2, obviously. But do it for this one. Take 11.559 divided by 23.1. Do we get 1/2 or something really, really close to it?
Yeah.
So sine of b is still 1/2 despite it being different numbers. Take the cosine, right? Cosine is adjacent over hypotenuse. So in this problem, adjacent over hypotenuse would be square root of 3 divided by 2. Tell me what that is as a decimal, please.
0.866.
Okay, they do the same thing, but cosine for this one. So that would be 20, the adjacent, divided by 23.1. It should be 0.866 or very, very close to it. Because again, we're getting close answers by rounding.
0.865.
Look at that. That's how we know we did it right. Is the ratios that were true for this thing are also true for this thing. And there's only one left, it's tangent, but I promise you, it works. It has to work.
Suppose.
Yes, sir?
I thought we couldn't be square root in the denominator.
Let me tell you a dirty secret. In algebra, you're not supposed to have radicals in the denominator. In trig, we focus a lot more on decimals. And so radicals in the denominator, I am much more comfortable with. Just because I'm going to tell you to grab a calculator and give you the decimal. Now, there will be times when I tell you to fix it. Usually those are problems where I want to have like an exact answer in proper form. So like you'll notice that for many of these questions, it says find an answer to 4 decimal places. So I will tell you this. Why am I okay with accepting this answer? 40 over square root of 3? Because this will tell me what the decimal is without me having to do any more work. I just type in 40 divided by the square root of 3. Whereas if I take the time to simplify that down to have a radical not in the denominator, I get 40 square root of 3 over 3. I'm still going to type that in the calculator and get the exact same answer, but I just did twice as much work. And so if the problem says for decimals, I'm going to leave that radical in the denominator and be like, calculator's doing it for me, get over it. Okay? Yes, you should not have a radical in the denominator. I'm focusing on decimals. Alright? Yes, ma'am. Sure.
They gave you 15.
15? Sure. What do you have? Okay, so 13 will go here, right? So this side is little a.
Wait, do I have to draw 2 triangles
That
from
side is
the
little c.
two?
You say 1 tangent, right? So tangent would be a over 6.
Oh, so we're doing like
So,
maybe you draw the picture.
So you do a over 6 equals 5 over 12. Here, it's a tangent of this one. So different for equals the tangent of this one.
How do you know what you do?
You can do both. And just some of them double. Like, let's say you did sine. Look at this top picture. What would be the sine? So with these numbers,
It would be A and C.
you can't do that because it's 2
Then
variables.
the other two.
So I have to take sine. What about cosine? Careful. A is adjacent, not A in the picture.
It's tangent.
Because the A in the picture is the opposite.
It's tangent of A.
That's separate to midpoint. There's A that's adjacent, and there's the A that's in the opposite angle. So cosine number is adjacent over hypotenuse. We have one variable and a 4 is good. So cosine is good, and tangent is good. Sine is not. So you cosine equals, so here's the picture.
So you are not going to be like to the
over
north.
hypotenuse. Good. Another picture.
Over adjacent.
What's the other side of this
I can
picture?
do 6 over 8.
Okay, and then you say the tangents.
17.
You can do any of the 3, but one of them will always be bad. Because that's 2 variables.
I thought it was opposite over adjacent.
So on 11, we took it a little faster because we skipped the 8 to do the other triangle.
So 5 times 6.
Let's start off with this.
So just 2.
So just 11, you set up these two fractions on 11 using cosine. So you made 2 triangles. Then you pick cosine because cosine has one variable out of the 4 numbers. If we
Okay,
come
and
back to
then
this one,
I have to solve
and
for
then
C.
this would be here. Even sine in this picture, B over C. That's can't be done. So this cosine
Now
will
we
play
see.
with C.
Now you're using this. Never mind.
And if and this is the and that would equal the tangent of this picture.
Oh, okay.
Okay? You always look at get one one grade.
So we don't have to be 15 about out of time, but what is angle? What is the one thing in front of it?
Gotcha.
Those are different than the other ones.
This symbol just means the angle is 60 degrees. So it's actually a lot like these ones.
So what's the difference?
This one asks you to find the length of each side of 4 decimal
No, I mean
places.
like from the other ones, like from let's say 12. What's the difference?
Nothing.
Are we gonna talk
It's
about
actually a lot more like 37.
Oh,
Okay.
Are we
42?
gonna use it in tomorrow?
Yeah.
okay, right.
42? Okay, I will probably not get all the way down, so we have to have a stopping point.
Just give me the basics of it.
Basics?
I'll figure it out. I just don't understand how you're supposed to count.
Gotcha. Ready? Picture. Okay, 63, 82, 39. Ready?
Mm.
And it says we want to find x, which is this bottom number.
Yeah.
What I would tell you is x would simply be this side, which we call A, and this side, which we call B.
Yeah.
X will equal A plus B. So what you could do is you could do just A.
See, that's what I was thinking of doing, but I don't know how to get it.
Well, this is now like 37. So we use tangent. You have opposite adjacent and the angle. So we do tangent of 63 equals 82 over A.
Okay, I understand now.
Then find A, then over here you do something similar, but to find B, and then you add them together to get X.
Got it. Okay, cool.
Same for 43. If you still have questions on it, we'll go over it tomorrow.
Are we gonna, is it a homework tomorrow?
The plan is to have the homework due tomorrow, but I might extend it to have it due over break if people are able to turn it in over break.
I don't think we can get it done, but I'll see.
Okay. I may have it end up being due like Sunday or something, and give you a couple more days.
I love the color.
Thank you.
If I'm even still alive by Sunday.
What you talking about? You dying on me, honey?
I'm just gonna fall asleep and never wake up.
My
That's a
allergies
poor
are
decision.
keeping my sleeping
That's
back.
I'll fall asleep and somehow never wake up.
Anthony won't?
I literally might. Actually, I can't even fall asleep.
I know, because you can't
He's
breathe
like
in
you,
that.
kid.
I'm like dying.
I
Yeah.
cannot
Four?
be comfortable to sleep.
I know. That's what happened to me one night, one day.
Not even like one.
Like, I didn't sleep. And then,
I'll give the other couple on Discord.
Yeah, we do.
Like, well, they probably won't even have enough of their team. Might have to forfeit you guys. Which. Okay. Thank you for letting me know. Does that mean you're not going to be here at school?
I mean, I can as long as.
Do you drive?
Yeah.
If you wouldn't mind, just in case we need you for the other team.
Yeah, I'll see.
I may just have you swap in for B team.
Okay.
Okay, here we go. Let's.
Yeah.
Okay.
I'll see. Go.
Have a good day, mister.
You too. I'm going to turn the video off.
Oh, dang it. Dang it.
As you deserve.
I was hoping I could get a little fun in it.
I lied.